Hello students, today's video is on the conversion of energy. Odd periods, this is due on Monday. Even periods, this is due on Tuesday. Now remember that we're changing things up a little bit and that your homework notes should either go in your notebook starting from the back, or you can use a packet of loose leaf papers, but please make sure they get stapled together. You should use the entire page for notes, so don't stop halfway through the video and stop taking notes. Please use, again, the entire page. And remember that on Monday or Tuesday you will have an open note quiz based on what you have in your notes. So we're starting a new unit, and this unit will be over energy. It will also be over alternative energy, but we'll talk about that later. And this says that I can describe how energy is conserved and converted between non-mechanical and mechanical energy, and describe the relationship of energy to work and power. Today we're going to be talking about this part right here, the conversion between non-mechanical and mechanical energy. Non-mechanical energy, we're going to talk about the types of it, and we're going to describe how they're conserved or converted, at least a few examples. Mechanical energy, we're just going to define potential and kinetic, and we'll describe, again, situations in which they are converted. Now, energy in and of itself has a really strange definition because it's not very specific. It's a property of objects. Property of objects that can change. All right, so there's this big idea: it can change its form, and it can move. So these are the two big things that we need to know. It can change and it can move between objects. There are two types of energy. The first type is a mechanical energy. Mechanical energy just means energy of motion or position. So this is kind of the big stuff that we can see. We can see if it's in motion, we can see where it is. Non-mechanical, on the other hand, is going to be more of the small stuff, and you'll see later that this is whatever does not fall into the mechanical energy category, which is why it's called non-mechanical. Now, mechanical energy, there are two types of that type of energy. The first type is called potential energy, and potential just means the possibility. It is actually there, possibility, but it's not quite moving yet, so we think of it as potential. So this is the energy to its position of an object above the earth. So for example, if I have a hand, this is my beautiful hand, and I'm holding an object above the earth, based on its position, it's going to have potential energy. Now, kinetic energy is the energy actually due to motion. So this is when something's actually moving or it has a velocity. So in this case, for example, if I were to drop the box, by the time it reaches the ground, it should be moving really fast. So this would be kinetic energy. Now, an object can actually have just potential, in this case, by itself. It could have just kinetic by itself, or it could actually have both energies. So let's imagine that my box is above the ground, which means it has position, which means it has a potential energy, but it's also falling. It's not falling quite as fast, but it's on its way towards the ground, so this would also mean that it's moving. So this would be both potential energy and kinetic energy. So again, an object can have both, so keep that in mind. Now, for non-mechanical energy, there are some types of non-mechanical as well. The first type is going to be sound. Is going to be acoustic, and the definition of acoustic energy is anything that you can hear. So this is going to be due to sound. The next one is going to be chemical energy, which we see in food, in fuel, in other words, in chemicals. So all food, all fuel, those are chemicals. We'll have electrical energy. The purest form of electrical energy that we really see is going to be lightning, but we harness electrical energy all the time in anything that uses electricity. So for example, your phones, right, your computers, the house lights, and even your cars, can use electricity. So there's a whole lot of times in which we see electricity being used around us. Radiant energy is the energy due to light. We'll be talking a whole bunch about how the sun is emitting radiant energy. This is the sun emits kinds of light called UVA and UVB, and those are the things that are actually cause us to need sunscreen. So what's happening is that the radiant energy is actually hurting us. So radiant energy, that's anything that's light. That could be the sun, it could be a light bulb. This is my light bulb right here. And the last one is going to be thermal energy, and thermal energy is heat. So if you think about fire, that is going to be thermal energy, or any time that you feel any type of warmth. So just so that we don't get confused, I'm going to go ahead and write a mind map for you. So if we're talking about energy, remember we have two big categories. The big categories are mechanical energy or non-mechanical. But underneath mechanical, there are two types over here. There's potential energy, which we said was due to position. We said that there's kinetic energy, which is due to motion. Under non-mechanical energy, we said that there was acoustic, which is sound. We said that there is chemical, which is food or fuel. We said that there is, what comes next? Electrical. So we said lightning or electricity. There's also going to be radiant, which is light from the sun or from a light bulb, for example, and thermal, which is going to be heat that we feel. Now the really important point of today is that energy can be transformed. Another word from transformed is changed. So it can be changed or transformed between the different types of energy. So for example, dropping an object, we saw that earlier, that the object would start with potential energy, and that would change into kinetic energy. Plugging in a toaster, obviously the plugging in part starts with electrical energy. And then it heats up our toast, so we end up with toast from thermal energy. Fueling a car, when we put fuel into a car, put gas into it, that's going to be chemical energy. And then the car is able to actually drive, so that would be kinetic energy. So again, we can see it transforming from one type to another type, one type to another type, and several transformations can happen. We've got a flashlight, again, that would be a chemical energy, because, for example, a battery, right? A battery has chemicals in it, so that's a chemical energy. And then obviously you're able to get light, so that is going to be the, radiant energy. Photosynthesis is kind of actually the backwards of that. We have the sun that goes on to plants, so the plants take in radiant energy. And from that, plants make sugar. And so that sugar is going to be a chemical energy, which is why we can eat them, because this is a food. And finally, another example would be wind chimes, which wind is moving, so that would be a type of kinetic energy. And when it hits the chimes, they hit each other, and that causes noise, so that would be an acoustic energy. Again, they can be transformed. Now, you don't need to write this down. You do need to do the assignment, though. Remember that your first assignment for our project Design and Dine is on sustainable energy systems research. Remember that's due at the start of class, the next time I see you. To get a 4 on this, you need to do 3 diagrams of different sustainable energy systems. They need to be detailed, labeled, colored, and understandable. If you have anything less than 3 diagrams, you will receive a 1. If you have all 3 diagrams, but you're missing a couple things, you'll get a 3. If you have all 3 diagrams, but you're missing a few more things about them, you'll get a 2. And remember that if you would like to get extra credit, extra credit, my favorite, especially after we just had a crazy exam. If you'd like to get extra credit, go ahead and do 1 more energy system. Same thing, has to be detailed, labeled, colored, and understandable in order to get a 5. Now, when I say sustainable energy systems, what you're going to want to look up when you answer this question number 1, you're going to want to look up sustainable. What does that mean? What is energy? We've kind of talked about it, but then combine them together. Sustainable energy. You could also look up some synonyms, which are renewable energy. We've talked about conversion of energy. You could look up alternative energy. All of these things are what you're going to want to look up in order to find the 3 characteristics. Now, when you're making your actual diagrams, you're going to probably want to look up, after you've looked up the different types of sustainable energy, you're going to want to go ahead and look up how does solar energy work, for example. So I could say solar energy, which is the one type I've told you about, but there are definitely several other types. So you're going to want to look that up on Google, and then because you're drawing a diagram, you're probably going to want to look at Google Images and actually look for your diagrams. So again, write your title here. You're going to draw your diagram here, and it's going to look really beautiful. Whoa. Make sure that it is colored. I'm going to have a red sun right now. Make sure that it is labeled. So here is my sunlight. And make sure that it's understandable. I don't know how understandable this is because it's not finished, but you can do better than I can. Don't forget to write your 2 to 3 sentence description, blah, 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 blah. Describe what is up here so that when someone looks at your diagram, if they don't understand something about it, they can go ahead and read about it. And last but not least, super important, you have to include that link. Again, if you do all of this, and you do 3 of them really well, and then you also do a 4th one really well, I will give you extra credit. That's it for today. Remember that you have an open note quiz on this video. Make sure that you also complete that research assignment by the start of class the next time I see you, because your group is counting on you. I will see you guys later. Bye.